In today's technology-driven world, software applications have become ubiquitous, permeating every aspect of our lives. From the apps we use on our smartphones to the complex systems that power our businesses, software plays a pivotal role. However, with the increasing complexity of software comes the potential for defects and errors. Software defects can have far-reaching consequences, leading to financial losses, damage to reputation, and even safety hazards. Software quality assurance, or SQA, is the systematic process of ensuring that software products meet predefined quality standards. It is an integral part of the software development lifecycle, encompassing a range of activities aimed at preventing defects, identifying and resolving issues, and ultimately delivering high-quality software that meets user expectations. Effective SQA is essential for building robust, reliable, and user-friendly software applications. A structured approach to SQA is crucial for achieving optimal results. The STAR model provides a comprehensive framework for planning, executing, and managing SQA activities. By adhering to the principles outlined in the STAR model, organizations can streamline their testing processes, improve defect detection rates, and enhance the overall quality of their software products. This essay will delve into the STAR model, explaining its components and illustrating its application in real-world scenarios. By understanding and implementing the STAR model, software development teams can establish a robust SQA process that contributes to the delivery of exceptional software applications. Unpacking the STAR model, a roadmap to effective SQA. The STAR model is an acronym that stands for Scope, Techniques, Approach, and Reporting. Each component of the model represents a crucial aspect of the SQA process, and together they form a comprehensive framework for ensuring software quality. Scope refers to the extent or range of testing, defining the boundaries of what will be tested and what will not. This includes identifying the specific features, functionalities, and components of the software that will be subjected to testing. Techniques encompass the methods and tools used to conduct testing. This includes various types of testing, such as functional testing, performance testing, and security testing, each employing specific techniques to uncover defects. Approach outlines the overall strategy and plan for testing, defining how testing will be carried out, the resources required, and the timeline for completion. Reporting focuses on documenting and communicating testing results to stakeholders, including developers, project managers, and clients. Effective reporting provides insights into the quality of the software and helps drive informed decision-making. By clearly defining the scope, selecting appropriate techniques, adopting a structured approach, and implementing effective reporting mechanisms, the STAR model provides a roadmap for achieving SQA excellence. Scope. Defining the battlefield of quality. Defining the scope of testing is paramount to the success of any SQA endeavor. It establishes the boundaries of testing, ensuring that efforts are focused on the most critical aspects of the software. A well-defined scope acts as a guide for the testing team, providing clarity on what needs to be tested, the extent of testing required, and the areas that fall outside the scope of the current testing cycle. The scope of testing is typically determined by factors such as project requirements, available resources, time constraints, and risk assessment. For instance, a mission-critical application handling sensitive financial data will demand more rigorous testing than a simple mobile game. Similarly, a project with limited resources may necessitate prioritizing testing efforts on core functionalities while deferring testing of less critical features to later stages. Documenting the scope of testing is essential for maintaining transparency and ensuring that all stakeholders are on the same page. A test plan document typically outlines the scope of testing, including the objectives, in-scope and out-of-scope items, testing environments, and entry and exit criteria. By clearly defining the scope upfront, the testing team can avoid scope creep, which can lead to delays, cost overruns, and compromised quality. In essence, defining the scope of testing is akin to drawing a battle line, focusing resources and efforts on the areas most crucial for ensuring software quality. By establishing clear boundaries and communicating them effectively, organizations can optimize their testing efforts and maximize their return on investment. Techniques equipping your SQA arsenal. Software testing encompasses a wide array of techniques, each designed to uncover specific types of defects and assess different aspects of software quality. Selecting the appropriate testing techniques is crucial for ensuring comprehensive test coverage and maximizing the effectiveness of the SQA process. Functional testing focuses on verifying that the software functions as intended, meeting the specified requirements. This includes testing individual features, user workflows, and system integrations. Common functional testing techniques include black box testing, white box testing, and gray box testing. Performance testing evaluates the software's responsiveness, stability, and scalability under various load conditions. This helps identify performance bottlenecks and ensure that the software can handle the expected user load. Load testing, stress testing, and endurance testing are some of the techniques used in performance testing. Security testing focuses on identifying vulnerabilities that could be exploited by malicious actors. This involves testing for common security threats such as SQL injection, cross-site scripting, XSS, and denial of service (DOS) attacks. Penetration testing, vulnerability scanning, and security audits are essential components of security testing. Choosing the right testing techniques depends on factors such as the type of software being tested, the project requirements, and the associated risks. For example, an e-commerce application will require rigorous security testing to protect sensitive customer data, while a video game may prioritize performance testing to ensure a smooth and enjoyable user experience. Section 5. Approach: Strategizing for Success. The approach to software quality assurance outlines the overall strategy and plan for testing, providing a roadmap for the testing team to follow. A well-defined testing approach ensures that testing activities are aligned with project goals, resources are utilized effectively, and testing is carried out in a structured and systematic manner. The testing approach should consider factors such as the software development methodology being used, the complexity of the software, the level of risk involved, and the available resources. For example, an agile development environment may necessitate a more iterative and collaborative approach to testing, while a waterfall model may lend itself to a more sequential and planned approach. A test plan document typically outlines the testing approach, detailing the testing strategy, test levels, test environments, roles and responsibilities, and communication plan. It also includes information on test data management, defect tracking, and test reporting. The test plan serves as a blueprint for the testing team, guiding their activities throughout the testing lifecycle. A well-defined testing approach fosters consistency, reduces ambiguity, and ensures that testing is conducted in a controlled and manageable manner. It provides a framework for communication and collaboration among team members, stakeholders, and clients, promoting transparency and accountability throughout the testing process. Section 6. Reporting, communicating insights, driving action. Effective reporting is crucial for conveying the results of testing activities to stakeholders and driving informed decision-making. Test reports provide insights into the quality of the software, highlighting defects, areas of concern, and progress made. Clear, concise, and informative reports are essential for ensuring that testing efforts translate into actionable improvements. Test reports should be tailored to the specific audience and purpose. For example, a detailed technical report may be suitable for developers, while a high-level summary report may be more appropriate for project managers or clients. Regardless of the audience, reports should be accurate, objective, and easy to understand. Key elements of a test report include a summary of testing activities, a list of defects identified, their severity and priority, test coverage achieved, and recommendations for improvement. Charts, graphs, and other visual aids can be used to present data in a clear and concise manner. Regular reporting throughout the testing lifecycle helps track progress, identify potential roadblocks, and ensure that testing remains aligned with project goals. By communicating testing insights effectively, organizations can foster a culture of quality and drive continuous improvement. Section 7. Real-world applications of the STAR model. The STAR model finds practical application across diverse software development projects, demonstrating its versatility and effectiveness in real-world scenarios. Let's explore a couple of examples. Scenario 1. E-commerce website development. Imagine an e-commerce website under development. Using the STAR model scope, focus on testing core functionalities like product browsing, online payments, user registration, and order management. Techniques. Employ a mix of functional testing, ensuring features work correctly, performance testing, handling high user traffic, and security testing, safeguarding customer data. Approach. Adopt an agile methodology, integrating testing throughout development with iterative sprints and feedback loops. Reporting. Generate regular reports for developers, highlighting bugs, performance bottlenecks, and security vulnerabilities, allowing for rapid fixes and improvements. Scenario 2. Mobile banking application. Consider a mobile banking application. The STAR model guides the testing process as follows. Scope. Prioritize testing of critical transactions like fund transfers, bill payments, and account balance checks. Also, focus on user interface usability on various mobile devices. Techniques. Utilize a combination of functional testing, usability testing, ensuring user-friendliness, and compatibility testing across different mobile operating systems. Approach. Implement a risk-based approach, prioritizing testing for high-risk features like transaction security and data privacy. Reporting. Generate detailed reports for stakeholders, including the number of test cases executed, defects found and resolved, and overall system stability. These examples illustrate how the STAR model provides a structured framework for approaching SQA, ensuring comprehensive testing and ultimately contributing to the delivery of high-quality software. Section 8. Benefits of embracing the STAR model. Adopting the STAR model offers numerous benefits for organizations striving to enhance their software quality assurance processes. Structured approach. The STAR model provides a clear and structured framework for planning, executing, and managing SQA activities, promoting consistency and reducing ambiguity. Improved test coverage. By defining the scope of testing and selecting appropriate techniques, the STAR model helps ensure that all critical aspects of the software are thoroughly tested. Enhanced defect detection. The structured approach and comprehensive testing techniques employed in the STAR model increase the likelihood of identifying and resolving defects early in the development lifecycle. Effective communication. The STAR model emphasizes clear and concise reporting, facilitating effective communication among stakeholders and ensuring that testing insights are translated into actionable improvements. Increased efficiency. By defining clear roles and responsibilities and streamlining testing processes, the STAR model helps optimize resource utilization and improve overall testing efficiency. Enhanced customer satisfaction. Delivering high-quality software that meets user expectations leads to increased customer satisfaction and fosters brand loyalty. By embracing the STAR model, organizations can establish a robust SQA process that contributes to the development of high-quality software, reduces costs, and enhances customer satisfaction. Section 9. Conclusion: the STAR model, your guide to SQA excellence. In the ever-evolving landscape of software development, ensuring software quality is paramount to success. The STAR model provides a comprehensive and practical framework for achieving SQA excellence. By clearly defining the scope of testing, selecting appropriate techniques, adopting a structured approach, and implementing effective reporting mechanisms, organizations can streamline their testing processes, improve defect detection rates, and enhance the overall quality of their software products. The STAR model is not a one-size-fits-all solution, but rather a flexible framework that can be adapted to suit the specific needs of different projects and organizations. By embracing the principles outlined in the STAR model, software development teams can establish a robust SQA process that contributes to the delivery of exceptional software applications that meet and exceed user expectations. In today's competitive market, delivering high-quality software is no longer a luxury, but a necessity. By adopting the STAR model as their guiding principle, organizations can navigate the complexities of software development with confidence, knowing that they have a robust framework in place to ensure the quality of their software products.